Hey guys, today we are talking classifying polygons. So the first thing we need to discuss is what is a polygon? So a polygon is a closed plane figure with the following properties. So closed plane, remember that term from 1.1? Figure with the following properties. It is formed by three or more line segments that are called sides. Each side intersects exactly two sides, one at each endpoint, so that no two sides with a common endpoint are collinear. Each endpoint of a side is a vertex of the polygon. The plural of vertex is vertices. A polygon can be named by listing the vertices in consecutive order. So we can name this polygon A, B, C, D, E. Consecutive order doesn't always mean alphabetical order. You could also name it polygon A, E, D, C, B if we went around the other direction. Just name those points in order around the figure. So when we talk about classifying polygons, we're looking at different characteristics of polygons. So every polygon is either convex, let me fix that, convex, or concave. So when we talk about convex and concave, convex looks like the typical polygon that you think of. Nothing is going inwards. Concave, I always think of something as caving in. So this part right here is concave. And the way you can test is if I extend this line, it goes through and hits another side. So I can tell that this is concave because it's hitting this side across right there. Whereas if I extend any of these lines, it's not going through the figure anywhere. So that's convex. So concave, the figure is caving in. Okay, to classify a polygon, count the number of sides it has. I feel like you guys should know a whole lot of these, so pause the video now and try to fill in this table on your own. See what you remember from elementary school, and then we'll go through this table together. Alright, three-sided polygon is a triangle. A four-sided polygon, be careful that you didn't call it a square or a rectangle. Its least specific name is just a quadrilateral. Five-sided is a pentagon. Six-sided is a hexagon. Seven-sided may be one that you didn't quite remember. It is a heptagon. An eight-sided is an octagon. The nine-sided figure is my favorite. It is a nonagon. 10-sided is a decagon. Think decade. Your book doesn't actually name an 11-sided figure if you're curious. 11 sides is an undecagon. But you don't have to know that. A 12-sided figure is a dodecagon. I told you to think decade for decagon, 10. I also think if you know Spanish or French, this undecagon, like uno, dodecagon, like dos. So you add one more, you add two more. That's how I remember those two. Anything else within a number of sides, we just call an in-gon. So that doesn't mean that we call it an in-gon. If it has 132 sides, we write it as 132-gon. Okay, so you can also classify a polygon by side lengths and angle measures. So when we classify by side lengths, if all of the sides are the same, we call it equilateral. That means all sides congruent. If all of the angles are the same, we call it equiangular. That's all angles congruent. In the case that both of these are true, we call it a regular figure. So both equilateral and equiangular. Or it could be none of these things. And if it's none, we don't have to write none. Just know that it's an option. Whereas it has to be convex or concave. It doesn't have to be equilateral, equiangular, or regular. It may not be. Okay, so we're going to classify these polygons. So first we're going to decide, is it convex or concave? Then we're going to decide, is it equilateral, equiangular, or regular? And then we're going to name it by the number of sides that it has. So this first one, I notice that nothing is caving in. So this is going to be convex. I notice I see these 4 angle markings that tell me that all 4 angles are the same. So I'm going to call it equiangular. And then since it's 4 sides, it is a quadrilateral. So when you classify, you will have up to 3 things that you write down. All right, looking at this next one, I see that these sides are caving in here. So I'm calling this concave. Then it looks like it could be equiangular, but this angle is not the same as this angle, and we don't have any markings telling us that the angles are the same. So we can't call it equiangular, but I do see that all of the sides are marked, so we can call it equilateral. And if you count the number of sides that it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides, which we learned was a dodecagon. So concave, equilateral, dodecagon is how we classify that figure. All right, this one down here. Looking at it, nothing is caving in, so I'm going to call it convex. I see both sides and angles marked. So since both of those are marked, it is going to be a regular figure. And then it has 1, 2, 3, 4, 5, 6, 7, 8 sides. So it's an octagon. Convex regular octagon. Okay, this last question says, the head of a bolt is shaped like a regular hexagon. This word regular here is going to be important. The expressions shown represent side lengths of the hexagonal bolt. Find the length of a side. Okay, so regular means that all of the angles and all of the sides are the same. The reason that's important is because then I know that these two sides are the same length, so I can set them equal to each other. So 5x minus 1 equals 4x plus 3. Then I'm going to subtract 4x from both sides. So I get x minus 1 equals 3. I'm going to add 1 to both sides. So x equals 4. It wants to know the length of a side though, so just finding x doesn't work. So I'm going to plug into one of these, and it doesn't matter which one. I pick 4x plus 3. So 4 times 4 plus 3 is 16 plus 3, so 19 millimeters would be the length of a side. Alright guys, as always, if you have questions, come see me. I will see you in class.